Друзья, мы продолжаем нашу конференцию.
Friends, let's continue with our conference and let's move to our next topic, creative AI. You've heard about AI that creates logos, algorithms for ad videos, commercial videos, and even an AI which became a journalist of a major media outlet. How can artificial intelligence be useful with creative problems? We turn to Ed Newton-Rex, Product Director of TikTok Europe. Make sure you're active with your questions, and Ed will take your questions after the speech.
Hi, Ed. We're happy to see you today in our studio. How's your life today?
It's very good, thanks. It's very good. Nice to see you.
So you can start your presentation.
Fantastic. Thank you so much for having me. Hi, everyone. My name's Ed Newton-Rex, and I'm here to talk to you about creative AI, artificial intelligence that can master aspects of human creativity. I want to start with a Turing test. As many of you will know, a Turing test is a test in which a human tries to discern whether they're conversing with another human or with a machine. And the idea is that if you can't tell, then the machine passes the test and we can call it intelligent. So this is a slightly different take on that. I'm going to play you two pieces of music, one composed by a human and the other composed by AI. And I'm going to ask you to tell me, or rather to guess as we're online, which is which. So here is the first piece of music. So that's the first piece, and here's the second piece. So which of those was written by AI? Now, because we're online, I'm going to ask you to fix your answer in your head. If anyone watching, so I'm going to give you a couple of seconds to fix your answer in your head, no cheating. Make sure you fix the answer in your head. And I can tell you that it was the second song there that you heard that was the one composed by AI. The first was written by a human. Now, I've done this exact same test before in person, and I can tell you that I generally find it's about 50-50. People can't generally tell the difference between those two. So who am I? I am a classical composer, but also a technologist. I started the first startup in the field of AI composition. We built an AI system that composed original music autonomously. And last year, we sold it to TikTok. It was called JukeDeck. TikTok, I think, is the biggest platform for creativity on the planet. And I now head up product in Europe there. Today, I want to focus on creative AI. Where does it come from? How is it possible? How good is it? And what does it mean for the world? So where does creative AI come from? Well, it's tempting to think of creative AI as a modern idea, the brainchild of the 21st century. But in reality, it can be traced back to a brilliant and prescient woman who was one of the earliest pioneers of the computing revolution. And she was born over 2 centuries ago. Her name, of course, was Ada Lovelace. She was the daughter of Lord Byron, arguably one of England's greatest poets, and Anne Isabella Milbank, a fiercely intelligent woman with a particular interest in mathematics. At the age of 17, Ada Lovelace met Charles Babbage at a party. He, as you'll probably know, was an inventor who'd got the equivalent of £1.7 million of funding from the British government to design and build his difference engine for computing complex tables of numbers for use in everything from engineering to finance to navigation. Ada Lovelace so impressed him that Babbage invited her to see his difference engine at just the age of 17. But in truth, Babbage was already bored of this idea he was working on. He'd already come up with another idea, the analytical engine, The analytical engine would have a calculating unit, a memory store, a printer for output. And if this sounds familiar, it's because it's functionally a description of the modern computer. In the design of the analytical engine, Babbage essentially invented computing. Now, in time, someone wrote an article on the analytical engine in French, and Ada Lovelace, a friend of Babbage and who spoke French, translated that article. But she knew the engine so well that she was actually able to correct the errors that the article's writer had made. And she corrected these errors in a set of notes. And one of the remarkable things about these notes is that in them, she realized that if you could perform operations on numbers, as Babbage's engine was designed for, you could also perform operations on symbols that could be represented by numbers, the alphabet, say, or musical notes. So Ada Lovelace was really the person who realized what computers would one day be able to do. And in these notes, she said this: the engine might compose elaborate and scientific pieces of music of any degree of complexity. She not only predicted the advent of the modern computer, at the same time, she predicted the rise of creative AI. So the analytical engine, of course, was never built. It wasn't until the 1930s and 40s that computers finally came into existence. But true to Lovelace's prediction, it wasn't long after that that explorations in computer creativity started. One of the first serious attempts at artificial creativity was made by two academics in the US named Hiller and Isaacson in 1956, just 4 years after the university built its first computer, and in the same year as the term artificial intelligence was actually coined at a conference 1,000 miles northeast at Dartmouth. They set about creating a number of computer programs that could compose music. Key to the technology behind this was a program that ran on the computer at their university, a computer called ELIAC. And the program in question was a random number generator. If a machine can generate random numbers, it can make choices. You assign each option a percentage chance, you run the random number generator, and you let the output of the random number generator dictate which option is chosen. So Hiller and Isaacson combined this random number generator with a set of musical rules they wrote, and the computer followed a path through those rules, taking turns dictated by the random numbers. Hiller and Isaacson fashioned the output into 4 musical movements for string quartet and gave the resulting work the title ELIAC Suite, named after the computer on which the programs were run. And this was the first piece of AI-generated music in the world. Now, in the same year, 1956, there was the first commercial usage of AI-generated music. The computer company Burroughs ran an advertising campaign for which they used admittedly simple AI techniques to create a computer-generated song. It was called Push Button Bertha. This was the song in question. The lyrics were written by a human, but the tune was composed by a computer. So as soon as AI creativity was a viable possibility, people had started thinking up ways to apply it commercially. Computer-generated poetry got going only shortly after this, with a poem written by a Z22 computer in 1959 that was running software designed by a man called Theo Lutz, a computer scientist based in Stuttgart. This is the poem that his system wrote. Like Hiller and Isaacson, Lutz used a combination of hand-coded rules and a random number generator to create the work. It was a very simple program. It selected words from a set of words that he had taken from Franz Kafka's novel Das Schloss. So the result isn't really much to write home about. It's not necessarily great poetry, but it is the first example of AI-generated poetry that there is. So what about art? Well, computer-generated art hit mainstream just a little later in 1965. A neuroscientist named Bella Jules, working at Bell Labs, the research and development arm of AT&T, had been testing Bell Labs' random number generators. Again, we find these are key to AI creativity. But he wasn't actually thinking about creativity at all. He was a scientist. He was experimenting with plotting the sequences of random numbers that were outputted by their random number generator as sequences of colored dots. And the reason he was doing that is to see if they could more quickly be able to tell whether the random number generator was working well. The idea was that if you had lots of dots of the same color, it probably wasn't working very well. Or if you saw patterns, it wasn't working very well. These plots of colored dots ended up on the front of the magazine Scientific American, not intentionally as art, but as an illustration of a scientific experiment. But the front cover was seen by a man called Howard Wise in a stroke of luck, and he was an art dealer and a gallery owner in New York, and he got in touch with Jules when he saw this to suggest they put on an exhibition of the images in his gallery. So after speaking, they also got one of Jules's colleagues involved, a man called Michael Knoll, because he, also at Bell Labs, he'd been making computer-generated images there since 1962 for a good 3 years. Knoll had actually been inspired to start creating these images when a summer intern there had a bug in their computer program that had led, in the words of Knoll, to random graphical nonsense being output by the program, which the intern had joked at the time was computer art. Knoll took that joke seriously, and he started intentionally creating computer art soon after. Knoll's images are arguably the first computer-generated art there is. This one, called Gaussian Quadratic, actually became the first copyrighted piece of computer-generated art. Not before a debate with the US Library of Congress about whether or not copyright could actually subsist in a work created by a machine, a topic that people still disagree on today. So since the 50s and 60s, there has been a long history of further developments in the field of creative AI. To pick a couple of examples, an artist and engineer named Harold Cohen developed a program that he called Aaron, into which from 1973 until his death just a few years ago, he gradually coded a wide range of rules that enabled it to paint in a number of different styles, starting with abstract shapes and ultimately encapsulating everything from color and perspective to objects such as plants and people. Aaron's works have been displayed in the San Francisco Museum of Modern Art, Tate in London, and at other museums around the world. And a composer named David Cope, having been commissioned to write an opera in 1980 and finding himself with writer's block, developed a program that could effectively break down a collection of a composer's compositions into short musical phrases and recombine these phrases in intelligent ways to create what sounded like, and perhaps almost were, new pieces in the style of that composer. He called the project Experiments in Musical Intelligence, and it was so convincing at recreating these pieces in the style of these composers that an audience at the University of Oregon that included a number of musical experts were fooled into thinking that a piece that this program had written was in fact by J.S. Bach, arguably the greatest composer of all time. So why does this work? Isn't creativity impossible to simulate? Isn't there something special about creativity that means computers surely can't really do it? Well, maybe, but there is a large part of it they can do. To consider why, let's look at music. These 4 chords, if any of you are musicians, you may recognize them. They may not look that special, but the reason you may recognize them as a musician is because they are the chords not just behind one famous song, but behind all of these songs. 4 chords in the same order that lie behind all of these songs. How are all these musicians able to get away with what essentially amounts to copying each other? Well, as the British philosopher Cyril Joad put it, creativity is knowing how to hide your sources. And really, when you think about it, something like music, yes, it's complex, but on one level, it's also represented by simple numbers, and not even that many of these numbers. The Western chromatic scale, on which all Western music is based, has 12 pitches. The first movement of Bach's Well-Tempered Clavier, one of the most famous pieces of classical music there is, only has 549 notes, the whole thing. That's not a lot in the grand scheme of what's understandable by a computer. And this starts to give a hint as to why it is that computers can make inroads in the creative domains. Creativity is hard to define, but my favorite definition is this. Creativity is immersion, assimilation, and recombination. Creative people immerse themselves in a huge number of examples of their chosen creative domain. They assimilate the common features of the examples that they see, and then they recombine these ideas in novel ways. And what's interesting about this model of creativity is that computers are perfectly set up to do all 3 of these steps. Computers can be immersed in large data sets. They can assimilate the common features of those data sets. And once learned, there's no reason that they can't recombine those features in new ways. Now, the way I personally have come to think about creativity is this. Creativity is a combination of rules and randomness. In every example of AI creativity I've shown you, there is a random number generator and a set of rules for the machine to follow. You can think of the random number generator as a die, and the probabilities of choices for the computer to make as a sort of rule book. The rule book may get incredibly thick. It's helpful to think of it as boundless, as however detailed it is, it will always likely be missing some of the subtleties of the art form in question, just as no single human artist can hold the entire gamut of artistic possibility in their head. But however complex, it will still be navigable by the machine as a series of instructions to follow, which, when coupled with a random element introduced by a random number generator and introduced whenever a choice needs to be made, enables the machine to chart a course that's bound by rules, but that avoids predictability because of its random element. But this is also the major limitation of these systems, because the rules of creativity are so complex that it turns out it's incredibly hard to codify them. But of course, as I'm sure you can predict, there is a way around this, which I'll come on to in a second. So this brings us to JukeTech, the startup that I founded. JukeTech was the first startup in the space of AI music composition. Started 10 years ago, in 2010. I set out to build an AI system that could compose music. My background was as a composer. I wasn't a computer programmer when I started, so I learned to code in order to build the first version of our system. Like previous attempts at AI creativity, the first thing I did was build a complex system of rules. Essentially, I codified my own understanding of music theory. This took a long time, and music theory is complex. And I can actually play you the first piece of music our system ever composed now. Thrilled when I first heard this piece of music, because it was written by a computer. As you'll hear if you listen to it in your own time, it's not the kind of music that's going to get into the charts. It's not brilliant. But when we raised funding and we started hiring AI engineers, we integrated something that, of course, transformed the kind of music we were able to produce, which is neural networks, which of course, well, I don't need to go into them in too much detail. While I don't need to introduce them in too much detail, I will give you a very high-level summary of how we started using them for music generation, and this is very, very high level. As you know, I'm sure, the way a neural network works at its simplest is you have nodes and connections between those nodes, roughly modeled on how we think the brain might work. We're probably wrong about that. And then you show the network a picture of a cat, say, and this fires off messages along these weighted connections in the network. And you get an answer out of the other end, yes or no, does that picture include a cat? And to train the network, you tell the network whether or not it got it, well, one way of doing it, you tell the network whether it got it right, it goes back and adjusts those weightings and its connections, and it tries again with a new picture. And you do this enough times, and it learns how to tell whether a picture has a cat in it or not. Now, we took this idea and simply applied it to music, symbolic music, that is, the notes and chords that you would see on a page of sheet music. Instead of pictures, we show the network a short series of notes. And then we ask the network to predict what notes should come next. With enough training data trained on enough symbolic music, it starts to do this remarkably well. And this approach meant our music improved a lot. Here, I was going to play an example. I'll start this example. I think you probably won't be able to hear it. Tell me if you can hear this. That was an example of our music, and again, I can send that to you offline if you'd be interested in hearing it. Really, the music managed to get a lot better over this time period. So we took this technology and we used it as the underpinning for a website that video creators, so that's people making YouTube videos, could use to make their own royalty-free, unique music for their videos, which they didn't need any knowledge of music to do. So we basically gave them a way of making music with no understanding of music themselves. Over time, we had more than 1.5 million unique pieces of music created on our website, which looked like this. Now, perhaps most interestingly, we actually found that some people used the site not as we'd originally intended, for music, for video, but instead they used it to create music. They used it as backing music for vocal lines that they would write over the top. They were using it to empower themselves to compose music. And I think that this co-creativity between humans and AI is an incredibly powerful way of our using, as a society, AI creativity. So with this technology, we won TechCrunch Disrupt and an award at the Cannes Innovation Lions, which helped bring AI music much more into the mainstream. And we also did this, the first collaboration between AI and human artists, launching music in South Korea that was composed by South Korean musicians who used our system to generate material that they used within their own music. And then last year, we were acquired by TikTok. So what about neural networks in creativity, but outside of music? Well, this recipe wasn't created by a human chef, but is rather the product of IBM's supercomputer, Watson. They showed Watson tens of thousands of recipes. They added data from scientific studies on what people find pleasant at the molecular level, and they told it to produce new combinations of ingredients that it hadn't seen. Essentially, they taught it to cook. They gave it the ability to make up its own dishes. And the result is Chef Watson. There's even a whole cookbook of these recipes, which I thoroughly recommend. They're delicious. A neural network course were also what were behind something you'll know a lot about already, which was DeepMind's AlphaGo a couple of years ago. And also DeepMind's many achievements since then. Now, AlphaGo, as you'll remember, beat the best human Go player in the world, Lee Sedol, 4 games to 1. Is playing Go creative? Well, yes, especially, I think so, especially when you see moves like this. This was the famous move 37 of game 2 of the 5 games, and it's been described by professional Go players as a beautiful move. At this point in the game, it's common practice to place your piece on the 4th line in, but AlphaGo went against thousands of years of established wisdom in Go and played on the 5th line in. Now, this move was so expected, so good, that Lee Sedol, its opponent, had to actually leave the room to take a break. AlphaGo won the game, largely thanks to this move, and then the match. And I think there is a strong argument that ideas that go against established wisdom in this way start to look a lot like human creativity. Now, since Jukebox was acquired by TikTok, there has been another major innovation in AI music creation from a technology with a very similar name, Jukebox, which you may have seen, built by OpenAI. Now, what OpenAI did is they scraped more music for their training set than anyone else has ever used before. 1.2 million songs, along with lyrics and song metadata. They then created a neural network with 5 billion parameters, and this amount of training data, the size of network, means they can do amazing things. Their system creates audio sampled by sample, and I encourage you to give it a listen in your own time. It's capable of creating audio that sounds eerily like real musicians from the past, Frank Sinatra, say, or Elvis Presley. Now, because of this kind of thing, AI music is getting more and more prominence. And earlier this year, I actually had the honor of being on the judging panel for the first ever international AI song contest. 13 teams from around the world entered the contest, and there was a public vote for the best AI song run by the Dutch national broadcaster, as well as a vote of the panel. And what we, the panel, judged it on was not just the quality of the music, that was for the public to decide. What we judged, among other things, was how well did humans, software engineers, but also musicians, interact with AI? How well did they collaborate with AI in order to create this music? Just using AI to create music runs the risk of replacing human creators. And as musicians ourselves, this isn't something we want to encourage. But collaboration between AI and humans offers new, exciting opportunities, which I will come on to in a minute. The team from Australia won the contest, and I encourage you to Google it and give the winning song a listen, because it's really, really fantastic. In the art world, going back to art, 2018 saw the first AI-generated artwork be sold at Christie's, Portrait of Edmund Bellamy, it was called, and it was created by a neural network trained on existing works of art. It's sold at Christie's in the UK for $432,000. And the final example that's worth mentioning that you'll be hearing a lot about, I'm sure, during this conference is GPT-3 from OpenAI. You already know about GPT-3. OpenAI have built the most impressive text generation system ever built. To do so, they trained a network with 175 billion parameters, 10 times the size of any previous model, on a data set of around 1 trillion words, including the whole of English language Wikipedia. And what they showed, frankly, is that a truly massive network trained on a truly massive amount of data is capable of some really incredible things. So what can it do? Well, let's take a look. First it can write. Here, the bold text was fed into the model and it wrote the rest. So essentially what was asked for, screenplay, that was a crossover between film noir detective novel and Harry Potter, and GPT-3 starts writing that screenplay. And you know what? It's not half bad. Let me read just the start. Scene, a small dingy office, early morning, furniture, Salvation Army of the... this is really very impressive stuff. Or here again, the red text is what was fed into the model, and it sets up a conversation that GPT-3 then manages to bring to reality between the early computer scientist, again, Alan Turing, and the mathematician Claude Shannon. And it writes an entire conversation between these two geniuses. To pick just a sentence or two, halfway down here, Shannon, you mean to say we can influence nature without being directly part of it? Turing, yes, even random events do not happen at random. Our very perception of them shape them. So GPT can write, it can respond to questions. Factual questions, yes, but also deeper questions, like this one, in which the model is essentially asked what it itself can and cannot do. And you just have to look what it says. It says, you ask, can a system like GPT-3 actually understand anything at all? Yes, I can. Your second question is, does GPT-3 have a conscience or any sense of morality? No, I do not. It can translate between languages. It can write articles. It can, studies actually show that when asked to say whether an article was written by a human or by GPT-3, people can't tell. Again, blurring the lines of what's possible by humans and by machines. And it can also do other creative things that involve text. It can write guitar tabs because there were text-based guitar tabs in the training data. So it can sort of write music. It can understand natural language and follow instructions. In one example that you may have seen, someone built a website using the technology that lets you type in natural language describing a website that you want built. I want a large blue button that prints out the weather. And it will translate that into the code that actually builds that website. So, this is pretty incredible stuff, but it also, of course, has limitations. It gets things wrong. Here are just two examples. Firstly, human, how many eyes does a giraffe have? GPT-3, a giraffe has 2 eyes. Human, how many eyes does my foot have? GPT-3, your foot has 2 eyes. So, it's not like it has amassed some perfect knowledge of the world, but in a way that, that lack of perfect knowledge can almost fuel more creativity. And another example, human, which is heavier, a toaster or a pencil? GPT-3, a pencil is heavier than a toaster. So it doesn't have perfect knowledge. And because it's trained on data written by humans, and humans aren't always nice, sometimes, of course, it also comes out with things that are unacceptable. Racism, bigotry. One of the biggest problems with AI systems is that you currently have to train them on things that are human. And if humans are perfect, neither will AI systems be. There is something we need to, this is something we need to be incredibly careful of when rolling out AI systems, and is one of the reasons, I think, that OpenAI haven't made GPT-3 widely available. So what should we think about the rise of creative AI? What are the implications? First, the positives. Creative output will be more accessible. More people are going to be able to be creative and to use creative output. Whether you're using AI music as backing in a video or using AI images in a campaign you're running, it will be easier to source creative content. 2, art will be personalized. When computers can be creative, theoretically any piece of creative content can be personalized to the individual. Songs, text, images can be personalized to the individual, to their particular preferences, to the situation they're in. This is interesting artistically, but also will be very interesting for advertisers and marketers alike. And 3, creative AI will make us more creative. as shown by AlphaGo, creative AI can figure out and show us new concepts which we can learn from. Another top Go player that was beaten by AlphaGo had this to say: I lose the game, I study the game, and maybe I change my game. I think it's a good thing for the future. And what about the negatives? Well, really, of course, the big concern here, for me, is the future of creative work. We've traditionally thought of creativity as something inherently human. Creative jobs surely will be safe from machines. Looking at what's happening in creative AI, perhaps that's not the case. And this is already happening. iHeartMedia recently made 50 employees, including DJs, redundant, citing their investment in AI as the main reason. In my view, this is why it's incredibly important we continue to find ways of creative AI being used as a tool to complement human creativity, rather than something that just replaces it. And I will leave you with more of a philosophical question. Is AI creativity real? Is it creativity at all? The answer to that, in my opinion, is that we don't know and we perhaps never will. But that's not what's important here. What matters is not whether or not creative AI is the same as human creativity. What matters is the effect creative AI will have on the world. As the Dutch computer scientist Edgar Dijkstra put it, the question of whether machines can think is about as relevant as the question of whether submarines can swim. It's not about how they do it. What's important is the effect that it has. Thank you very much.
Ed, thank you so much for so interesting and amazing presentation, really. I'm sure that in the future we will see new interesting formats of creativity based on the joint work of artificial intelligence and humans. So we will follow this direction, and now let's answer some questions. The question number one, how do you think, what areas of creative AI will be in demand within 5 years?
I think the simple answer to that is that all areas of creative AI will be more in demand. I think one of the big things that we're seeing at the moment, one of the most exciting areas, is actually in something I haven't spoken about, which is in scientific discovery. There are already a number of companies that are working on applying AI systems to actually discovering new uses for existing drugs, for instance. And this is an incredibly exciting area of creativity. I mean, you would have seen the news about AlphaFold from DeepMind just a couple of days ago. This is an incredibly exciting avenue. I think not only will this be a very, very helpful thing and a very good thing for humanity as AI starts to be innovative in the scientific domain, but it will also provide good commercial avenues for companies working on this stuff. And really, that's what you need in order to build companies around the field of creative AI. So I think that's an incredibly exciting area that I look forward to watching grow and having an amazing impact on humanity in the near term. Because, I mean, we should remember, creativity isn't just about the arts. Humans are creative in a number of domains. And in my view, scientists and people making discoveries and breakthroughs are just as creative as musicians and artists.
Thank you, Ed. And do you think machines can become as creative as a person?
It's a very good question. It's a very hard question to answer. I think that, machines work very differently to people right now. I think what you've seen in this talk is probably not real creativity. It's a simulation of creativity, right? It is artificial. It is the artificial in the artificial intelligence. Ultimately, the big thing that machines can't write, they can't do a number of things. They still can't create music or art that is as good as humans. But, another big thing they can't do is they can't currently understand what they're doing. A machine it's not able to critique itself. It's not able to say, oh, that's not a very good piece I've just written. It's also not able to base its creativity on anything in its own life. I, as a musician, write music for my daughter, for instance. Like, that means something. A machine writes music because I tell it to. And so I think there are a number of ways in which machine creativity is a long way off being equivalent to what human creativity is. I think probably it will never quite get there, and I think that's a good thing. I do think there is something special about human creativity that we should cherish. But I think that in the meantime, we can derive a lot of benefit from machines that are able to emulate creativity.
Thank you, Ed. And what is missing now for building full-fledged model of making creative works of art? I
think one of the problems at the moment is is really just kind of not enough data, and not enough access for enough people to enough compute resources. You know, I mean, OpenAI are able to train on a huge data set that they've scraped, and are able to build massive networks. Not everyone can get access to that data, especially not commercially, because it's kind of commercial music. And not everyone can build those kind of networks and can run on as many servers as DeepMind uses and that sort of thing. So I think that's one of the major blockers. There's a lot of very smart people out there, but not everyone has enough resources to do, because machine learning takes a huge amount of resources, right? It's not just like me learning music, where I just have to get a music teacher and learn for 20 years. It takes a lot of resources, and only a few companies are really capable of doing that.
Yeah, I fully agree with you. And what is the best start for working in creative AI technology, in your opinion?
What's the best part of working in it, do you say? Yeah, I mean, the best part of working in creative AI technology for me is that it is, I think it is at the forefront of creativity in general. I think as a creative person myself, as a musician, what a creative person always wants to do is they want to be involved in the way the art is emerging and in the way it's developing. And right now, in my view, AI is the most exciting thing happening in the space of creativity, almost full stop. I think it is something that we will look back in the year 2100, 2200, and when asked what happened in art in the early 21st century, I think one of the big answers will be AI. It's probably why everyone here is interested in AI. It's because we're at a forefront with AI, and that's always exciting.
Mm-hmm. One question more. Now your model makes music based on existing melodies. Is it possible that in the future it can create a new direction in music, other than, I don't know, rock, hip hop, etc.?
I think it's definitely possible. I talked mostly about neural network. Yeah, there are other approaches people have used. Quite famously, one approach was using evolutionary algorithms, where there was no musical training data involved. So, a system learned by taking feedback from, it started creating random noise, took feedback from humans, and gradually sort of solidified into a musical sound. That didn't use any musical training data. It didn't use any existing melodies. So there are definitely ways of making machine learning and AI work without training on existing data. And because of that, I think absolutely. Another thing I would say, though, is even if you use existing data, trends rarely emerge in a bubble. A trend is usually a combination of previous trends anyway. That's how trends emerge. And I think that's actually something that, it's jazz, for instance, didn't just emerge out of thin air. It was a combination of various musical styles that came before it. And I think in that way, AI could absolutely be part of the next artistic and creative trends and the way those are created.
Thank you very much, Ed. It was really, amazing to hear you today, and thank you for your time.
Really, really big pleasure to be here. Thank you.
Thank you. Thank you, Ed. Каждый день мы с вами сталкиваемся с искусственным интеллектом.
Every day we deal with artificial intelligence in all kinds of areas. But are we prepared to interact with it, to work with it? And what kind of opportunities can there be for artificial intelligence? We will learn very soon at the OpenAI with Intel Quest. We're meeting back at 1300.